pretty honest. So there's two different ways to solve this one. How did you solve it? Somebody? How'd you think through it? You have to be able to explain to me how you got through it. Yeah.
Hey, that side has to be equal to -1.
This side needs to be equal to -1. So you're saying -1 equals I. -1 doesn't equal I. You mean the square root of -1 equals I? Oh, okay. How'd you do it?
I thought I knew that the square root has to be -1 under that, so I thought for it, if the square root of -1 equals the square root of x plus 2, you just cancel it all out and drop roots. And you solve the equation.
So you went through and solved algebraically?
Yeah.
Awesome, I like that. So I'm going to actually go through it algebraically like he did. So how do you get rid of the square? If we're just solving for x, how do we?
Square root.
Let's get the square root. How do you get rid of the square root?
Square.
So don't you have to do that to both sides of the equation?
Yeah.
So will that be x plus 2 is equal to I squared, which is? -1. So to get x and 1, what do we subtract 2? X is equal to -3. That is one way of doing it, algebraically. Now, Massa just said, I know, he thought through it. I know the square root of -1's I. How am I going to make this underneath a -1? Well, if we have -3 plus 2, that is -1, right? So you just thought through it. Equally good, okay? This was a problem on the end of level, so I'll get it right. Yay, okay? Okay. So today we're doing 7-4, piecewise functions. So first of all, piecewise function. It's just one function that is made up of pieces of other functions. That's why it's called a piecewise function. It's one function that's made up of pieces of other types of functions. So here's what a piecewise function will look like. F of x is equal to these big brackets with these different pieces. So we have this first function, x plus 1. Does everybody see that? We have the second function, x minus 3. Aren't they just both lines? Yeah? Is everybody good?
Yeah.
So we have two pieces of different functions. Now we only keep this function for x values greater than or equal to 2. So we would draw this line, we would only keep it for x values greater than or equal to 2. So this is kind of our domain restriction. Domain means x values. Now we have x minus 3, that's just a straight line. We would only keep that line for x values less than 2. So anything less than 2, we'll keep it for that. So it's just one function made from different pieces of other functions. So first of all, I need to remind you, what considers something a function? How do we know it's truly a function? So to qualify to be a function, two things have to be true. First of all, it has to pass the vertical line test, which really means, mathematically, the vertical line test means for every x value, there is only one y value. For every x value, there's only one y value. So this is a function, right? Does it hit my pencil in two places on the y anywhere?
No.
No, so it's considered a function. Because we know a parabola is going to continue growing like this, right? So does everybody understand how the vertical line test means does it hit my pencil twice in the same x point?
Never.
So if it does, it's not a function. Because that would be two y values at that one x. Does that make sense? Okay. So looking at, the next thing, guys. If your x values are continuous, they have to be a function. Meaning there's no break in your x values. So look right here. Do you see how there's a big break, a big gap in these x values?
Yep.
There's no function there. This is not a function. Now, you can have a break in your y values, however, as long as those x values don't have a break. So if this function breaks off and there's another function starting up here, as long as those x values stay continuous and don't break, you're good. So does everybody see how we're gapping the x?
Wait, will you explain that again? Like the whole...
Yeah, good question. Yep, okay. So you see how we have a break in x? I'm going to explain it better this time. So we have a break in x, so it's not a function. Now I'm going to change this line. Does everybody understand that part? I'm going to change this line, and I'm going to show you what would still be considered a function. So if we had a break in our y's,
Oh, okay, I get it.
if we had a break in our y's, that's okay. Because do you see how even though our x value stops here, it still continues here, onward. So this would be considered a function, and that's actually what a piecewise function is going to look like. Now right here, this is not a function because look, if I take and draw a vertical line, there's two y values at that one x value, right? So not a function. Yes.
I thought you said for every x value there can only be one y value.
Sure.
You have that when the break in the y, isn't there two y values?
Great question. I'm loving that you're asking this. So you're saying, well, there are two y values at that one x value, so it's not a function. Good point, but this has an open circle, so it doesn't include it. So that's how that fixes that. Good question. I'm glad you asked it. So because that open circle fixes it, open circle means not included, and it starts right at that value, there's still only one x value right there. Does that make sense? Good questions. Okay, so let's just start graphing these, okay? So it just comes down to practice with these. Pay really close attention and ask questions. So we're graphing this piecewise function. So this is one function. F of x is equal to, we have these two pieces. So I'm just going to, first of all, Leo. So first of all, this is how I teach this to make it a lot easier for us. Is first of all, we're just going to graph x plus 1. We're going to completely graph it. Don't we know how to graph x plus 1? Isn't that a line?
Yep.
So we have a slope at, you have to be able to graph lines correctly today. Don't we have a y-intercept at 1?
Yep.
And then it's been a slope of positive 1.
Up 1 over 1.
So up 1 over 1, up 1 over 1. So I'm going to draw in my line. Your lines have to be drawn correctly, so you need to make sure that you're really careful today. So I'm drawing in my line. Okay. Does everybody see how I just simply drew in the line? Okay. Now, I'm going to draw in this, x minus 3. We know how to draw that line, right? So, isn't that a y-intercept of negative 3?
Yep.
And a slope of positive 1. So we go down to negative 3, and a slope of 1 up 1 over 1.
Good job.
They are parallel. Good point. Because they have the same slope, right, Brendan?
Yep.
So that would make them parallel. Good point. Okay, so guys, as of right now, is this qualified to be a function?
Yes.
No, right? At this x value, isn't there two y values? Okay, so as of right now, it's not a function, but piecewise functions fix that. So now we're going to focus in and look at what we're looking for. So we're keeping x plus 1 for x values greater than or equal to 2. Does everybody see how I read that? We have x plus 1. Isn't that this red line?
Yep.
We're keeping that for x values greater than or equal to 2. So find your x value of 2. Does everybody see how this is 2?
Yep.
Is everybody good with that?
Yes.
So now I'm going to draw in a highlight here. So we're going to be restricting about this point at this x value.
So anything on the right side of that is good?
Yep, so we're keeping x plus 1 for x values greater than or equal to 2. So greater than or equal to 2, wouldn't that be this way? Aren't these the x values greater than or equal to 2? Now notice a little trick. Do you see the arrow pointing that way?
Yeah.
That's your good to go because you're keeping the one that points this way. So you're keeping that side. Does that make sense, everybody? So we've got to erase anything below, starting from that x value. So we're starting at x is equal to 2 on this function, and we're keeping it for x values greater than 2. So we're keeping the above. So we're going to erase anything below. Do you see how I've eliminated that function now?
Only on the red though.
Only on red. We've only done red so far. Now it was x values greater than or equal to 2. So did it touch down right at 2? Did it include 2?
Yeah.
Greater than or equal to 2. So it started right at that value of 2. Is everybody comfortable up to there? Okay, now let's do this other one. So we're keeping x minus 3 for x values less than 2. We're keeping it for x values less than 2. Once again, do you see how my arrow's pointing this way? You're going to keep that side and erase the other side. So I'm keeping the below, or this way, I'm erasing the upper side. Does everybody see?
Don't you erase the 2?
Good. So we won't erase the 2, but we will have to draw since it doesn't include 2. As of right now, it's not a function, but it doesn't include 2. So we would specify that by a big open circle at 2.
No.
And we're done. We've drawn our piecewise function. So it just takes some practice. Let's do another one. Okay? That's it. We've drawn the function. Pieces of different functions. Okay, we're going to do another one. It's actually this is a hard lesson for most students. Okay, let's do another one. Okay? Okay, so let's do this one. So the problem is most people can't draw in a line correctly. So looking at this piecewise function, our first piece is 2 minus 4x. That's not in y equals mx plus b form, right?
Yep.
So let's rewrite it as negative 4x plus 2. Isn't that the same thing?
Yep.
Okay, closely pay attention. It was people messing up on drawing negative sloped lines. So we're going up 2. That's our y-intercept. Now we're going down 4 over 1. We always go to the right one when starting out our slope. Down 1, 2, 3, 4 over 1. Okay, are you good up here? Okay, so do you see how I have this line? Okay. Oops, I kind of missed that last one. Okay, so now I'm going to graph 2x plus 3. So, sorry, I was just trying to think of maybe I should do something different, but let's just keep going. So up 3, then it's a slope of up 2 over 3, right? Up 2 over 1. Did I say up 2 over 3?
Yeah.
Sorry, I'm thinking about all this stuff at once. Up 2 over 1, down 1, 2 over 1. So I'm drawing in my line. Okay. So we'll do the same thing we just did, because right now it's not a function. It's not looking so good. So we're restricting it at -1, right?
Yep.
So we're restricting it on this value. Now, that's why you have colored pens on your desk, is to draw this line, because it gets really messy when you're drawing with pencils to remember what's what. So that's x is equal to -1. We're right here, right? Okay. So now let's erase what we need to erase. So we're keeping this one. This was the first one I drew with the negative slope, the red one. We're keeping it for x values less than -1. The arrow's pointing this way, so we're going to keep this way of the function. We'll erase everything on the other side. Does everybody get that? So I'm erasing this side, right? From the yellow line. So, it's kind of hard with these huge erasers. So I need to be erasing clear to there, right? On the red one. Ignore the purple one.
Yeah.
I'll have to draw that back in. Okay, so now we're keeping this line, the purple line, for x values greater than or equal to -1. So the arrow's pointing this way, so you keep the one above. So we need to erase below, right? Okay, so now I'm going to go back, fill in this was still there. And then let's open circle it, close circle it. So wasn't this one not including? So that should be an open circle right there, right? And then this one was including -1, so close circle. Is everybody comfortable with that one?
That's a function.
Yeah, because look, continuous, it passes the vertical line test, it's continuous, right? It stops here, but doesn't it start there on x?
Yeah.
And continues that way? Yep, it's a piecewise function. Questions?
Can it only be a piecewise function if one of them is inclusive and one of them is not inclusive?
Yes. Good question. Okay, so we're going to do another one, and I'm going to try a different tactic on this one. See which one you like, and then if you like one over the other, go for it. So we're going to plot each of these. So we have y is equal to -5. Does that have a slope at all? Nope, no mx, right? So isn't that a y-intercept of -5? So we're going down -5. There's no slope, so we have a straight line like this. So now watch this tactic. Are we going to keep that for x values greater than 0? So I'm going to go ahead and erase it right now so there's not so much going on. Does that make sense? So we're keeping that for x values greater than or equal to 0. So we're keeping that side, right? From 0. So I'm going to erase anything below. Now there's not so much going on. Does that make sense, everybody?
No.
I erased below because we're keeping that line for x values greater than 0.
Okay.
Okay, so then this is the line, okay? And it included it, so it's a closed circle. Okay, so then let's graph this one. X minus 1. So we have a -1. Then our slope is +1. So our y-intercept was -1, slope of 1. And then we can keep graphing it. And then we're only going to keep that for x values less than 0. So when we erase anything above. That was not drawn in very good. So we'll erase above 0. So here's 0, I'm erasing above. Now you've got to make sure that your closed circle, open circles are good. So looking at this one, needs to be open. Because it did not include 0. So if you want to erase one from the get-go, there's not so much going on. That might be better. Does that make sense? Did that one seem easier? Okay. Last one, then I'll just let you work for a long, long, long time. So stay with me. I know it's been a long time since I've been up here talking. Let's just do this last one, then I'm going to let you just work for a really long time. So we have this piecewise function. This one has 3 different functions. That's okay. We can go ahead and graph them. So we're going to graph this one, x plus 3. So that's a y-intercept of 3, up 1 over 1, up 1 over 1, right? Are we all good?
Right.
So we have this. Okay. So now we're keeping that. I'm going to erase right here so we don't have so much going on. We're keeping that for x values less than 4, right? Everybody? Keeping that for x values less than 4. So, no, I didn't draw that very perfectly. So less than 4. So I'm going to grab my eraser. Where's 4? Right here? So I'm going to go up. So x value is less than 4. So we kept the arrow pointing this way. Does everybody see? So you might still want to draw in your little line. That will probably be helpful. Aren't we talking 4? Isn't 4 our restriction?
Yeah.
Okay. Does everybody see how I kept that line for x values less than 4? Am I confusing you?
No.
Okay. Sorry, it's just a lot going on, I know. So then we have this one. We're graphing negative x minus 3. Careful with this. So we're going down 3. Then we have a negative 1 slope. So you go down 1 to the right one, down 1 to the right one, down 1 to the right one. Up 1, over 1, up 1, over 1. Okay. So now we're keeping that for x values greater than 4. So wouldn't that be above 4? Greater than 4. Aren't we keeping those ones? So I'm going to erase those dots because I didn't want to have to draw it all in. Does everybody see how I kept it for x values greater than 4? Did it include 4? Not either of these. So I'm going to open circle them. And then we'll graph negative 7. So we have a straight line at negative 7. So that'd be right here. But we're only keeping that at x is equal to 4. So at x is equal to 4 is the only place we're keeping it. Isn't that right where that open circle was? So don't we just fill it in? That's the only place we're keeping it though, right? At x is equal to 4. So we've got to erase everything else.
Oh. Okay.
So then it fills it in, which is nice because look, then it makes it a function. Okay.
I get it. Yeah.
So you have a straight line at negative 7. We only keep it at 4. Exactly 4.
Can it work?
Yes. So do the front page. Go. So looking at this one, we're not only going to graph lines. We're going to have quadratics and we're going to have exponentials. But we know how to graph all of them, right? If you don't know how to graph them, can't you plot in y equals plot points? So that's what we're going to do. So let's graph the line. So we have the line 2x minus 4. So that'd be down 4. And then it's positive 2 slope. So up 1, 2 over 1. Okay. Okay, so I have that line. We're keeping that. That was a really wiggly line. So we're keeping that for x values greater than 3. So I'm going to draw in my restriction, isn't it, at 3? So I'm going to draw in my restriction so I don't have so much going on. We're keeping that function for x values greater than or equal to 3. So erase below. And it's equal to, so it's a closed circle on that purple line. Is everybody comfortable so far? Now to graph this next part. We're graphing 3x squared. So if you don't know how to graph it, plot a bunch of xy points. Go. Type in your calculator, y equals 3x squared. Hit second table. Go to the table of values. So give me some values. So some points. 0, 0. What are some more points? 1, 3. Also negative 1, 3. So we go over 1 and up 3. Negative 1 up 3. What's another point? 2, 12. Okay. So over 2 up to 12. Clear up there. And okay, so this one, no, and then this one goes off the graph, right? So it's going like this, or quadratic. Okay, so we'll keep the quadratic for x values less than 3. So doesn't that include everything on this side? So it would end up touching that purple line clear up there, and that's where we'd stop it. This was kind of not the best example. So it doesn't include it, so it would be an open, it doesn't include 3, so it'd be an open circle clear up there somewhere. Okay, one more. This one's a little bit better. It doesn't go off the graph. Sorry about that. So it says graph the piecewise function. So let's graph negative 2x squared. Give me some xy points. 0, 0. Negative 1. Negative 2. So negative 1, negative 2. 1 and -2. 2 and -8. Okay, so I have this quadratic that's flipped upside down. Makes sense. That negative in front with a flips our quadratics upside down. Now our restriction's at 0. So our restriction's at 0. That's this value. We're keeping that one for x values greater than 0. So we're keeping this side, right? So I erase below. And it doesn't include it, so it's going to be an open circle right there. Okay, so now let's plot this one, x squared, which I know is 0, 0 over 1 of 1 over negative 1 of 1 over 1 of 1, 2, 3. You could just plot these points though. Okay, so we have this quadratic on the other side. Now we're keeping that one for x values less than or equal to 0. So that means below, so we'll erase the above the purple line part. And it includes 0. So here at 0, 0. So it's a closed circle. So it closes off that open circle. Did everybody see how I did it? So it's just the same thing. It's just they're not always going to be linear. Okay, I don't want to have to do this one. First I was able to go ahead and do the back page without me. We know how to graph these, right? If you don't, couldn't you just plot a bunch of XY points and draw in a graph?
Yep.
Okay, so I don't want to spend any more time up here than I need to. I'm going to let you just continue on to the back page.